Hello everyone, welcome to Anu's classroom. So in this video we are going to discuss a few of the term and examination numericals that have come up from hypothesis testing concept. Okay, so what is hypothesis testing and what are the problems that have come up from hypothesis testing and how to solve them, all those things we'll be looking at in this particular video. So this particular topic, actually hypothesis testing, it is a very important topic for you in your MMPC 5. Because for one thing, there have been numericals, there have been theory questions from this particular topic as well, and also not just that, the importance of hypothesis testing does not end with your first semester. It goes on in your upcoming semesters as well as in your actual managerial work also, because as you all know, if you have taken MBA from IGNOU, then you will be required to complete a project work. A thesis work will be there in your third semester, right? So in that also we will be using this concept of hypothesis testing. Most of our regular project work topics are hypothesis testing topics only, because it is easier to execute as well. So most often you guys will be choosing a hypothesis testing kind of a project. So why I said this is not to scare you, but to drive the importance of this topic. Okay, study this topic very well, understand what hypothesis testing is, how it is done, what are the important concepts, all those things, the various tests, all of that, as much as you can study it thoroughly. So in this video we will be discussing numerical questions which has come up in this particular topic. But before we start with the actual question answer session, I want to give you a quick recap of what hypothesis testing is, so that you will be able to follow along the video in the solutions better. I hope it is going to be okay. If you guys are already familiar and you don't feel like there is a requirement as such from your side to have this what you can say theory session, theory part of it, you can always skip ahead and go to the actual question answer solution. Okay, so anyway, for those of you who want that recap, let's have it here itself. Hypothesis testing is actually a statistical method which is used to make inferences about a particular population, and this is based on a sample data. So it basically involves formulating two competing hypotheses which competes with each other. One is a null hypothesis, which says or which assumes that there is absolutely no difference or no effect, and the other one, on the opposite side, we have the alternate hypothesis, which suggests that the null hypothesis is wrong and there is an actual effect or difference. So that is basically the null and alternate hypothesis. So that is a very, very important aspect of this hypothesis testing. Now, the whole concept of hypothesis testing is we are going to investigate which of these two hypotheses, null or alternate, is the right one. Right. So as our goal is to test hypothesis, say usually we test hypothesis for about a population. Like for example, say if your topic is let's say internet usage among youngsters. Maybe we can say that the type of phone is not directly related to the internet usage or the internet speed. Null hypothesis would be like internet speed is not related to internet usage. Alternate will be yes, internet speed is related to internet usage. The speed of your Wi-Fi is related to the amount of time you spend on the internet, something like that. Those will be your null and alternate hypothesis, right? Now, if you want to test for this, will you go and talk to every person in this world to get data for your project? No. You will only take, maybe you will select maybe 50 or 100 people from around your locality. That is essentially, you will take a sample, and in that sample you will conduct this experiment, and you will project whatever you found from your sample into the whole population. So from a sample you are drawing inference or you are concluding something about the entire population. So that is what hypothesis testing is all about. We are testing a hypothesis about a population using statistical evidence from a sample, and based on that we will decide whether to reject or accept the hypothesis. So to do that, there are multiple tests which can be done. Mostly in this video we will be talking about the z-test and chi-square test. There are many other tests as well, but since this particular video is dedicated to term and examination numericals, I am not going into any of the other tests, because the tests, the questions we have are, one is using z-test and the other is using chi-square test. Only because of that we are going to focus more on these two tests only. So if our goal, as I said, is to test something about the population parameters using a sample, then we go for z-test or t-test. If our sample size is greater than 30 and if our distribution is assumed to be normal, then we go for a z-test. And if the sample size is less than or equal to 30, like a very small sample size, then we use a t-distribution, not normal distribution, somewhat similar but different, t-distribution, and we will go for t-test. Okay, but so that is one type of testing. What if we are asked to test if an observed categorical data fits some expected distribution, or maybe two variables, we are asked to test if two variables are independent of each other, or distributions across multiple groups are same, like comparison kind of testing. Okay, in that case we will definitely need a sufficiently large sample size, so we will be going for chi-square test in that case. When it comes to comparison testing, we will definitely need a very good sample size, a very large sample size, and we will be going for chi-square test. Okay, now these are not the only kind of test. There are a lot of other tests for checking hypothesis, like ANOVA and things like that. So as I said earlier also, explaining all of them is beyond the scope of this video. We will be looking into only z-test and chi-square test in detail here. Now coming to, as I said, the z-test and t-test, they are both used to compare sample data to the population, or even between two samples also. But there is a slight difference between these two tests, z-test and t-test. The major difference is in the sample size. And another difference is, when you are using z-test, then we have to know the population's standard deviation. If the population's standard deviation is unknown and we have to use the sample's standard deviation and the sample size is very less, then we go for t-test. Okay, so usually our questions assume normal distribution. That has been the case so far, and we will be given sample sizes more than 30. So naturally all the questions that have come up so far goes to z-test. So that is why we will be looking at how to perform a z-test for testing a hypothesis now. So how do we test for hypothesis using z-test? The first step in testing a hypothesis, whether you are using z-test, t-test, chi-square test, whatever it is, if you are testing hypothesis, the first step is the same. That is, you have to state the hypothesis. You have to write down what your null hypothesis is and what your alternate hypothesis is. Usually, null hypothesis assumes there is absolutely no difference. Like there is no relationship between speed and time traveled. That will be your null hypothesis. Alternate hypothesis will suggest a difference. Like, yes, there is a relationship between speed and time traveled. Something like that. This is just an example. Okay. So that is alternate hypothesis. So you need to have a null hypothesis and at least one alternate hypothesis. Okay. So that is the first step, no matter which test you are using. Now, to conduct a z-test, the second step is to select a significance level. Commonly, we go with significance level or alpha values 0.05 or 0.01. Usually, we go with 0.05 most of the time. Otherwise, it will be specified, or you need to have a proper reason why you are selecting something else, right? So even in our project work also, we will mostly go with this significance level of 0.05. Okay, so that is the significance level. Then the third step is to calculate the z statistics. So when you calculate the z statistics, we have the formula z is equal to x bar. X bar is the mean of the sample minus mu 0. X bar is the sample mean, mu 0 is the hypothesis population's mean, sigma is the population's standard deviation, and n is the sample size. Okay, so using this formula with all these values, we can calculate our z statistic. Once we have the z statistic, we can determine the critical value or the p-value. For that, we can use a z table to find the critical value or the p-value that is corresponding to the c statistic which we got in the third step. Once we have the critical value or the p-value and the z statistic, then we can compare the z statistic with the critical value or this p-value and use this particular rule to decide whether to reject or accept the null hypothesis. We don't accept the null hypothesis per se, we say fail to reject. It is either reject or we are failing to reject. We won't write the word accept anywhere, okay? And it is all, so naturally failing to reject null hypothesis automatically says that we are accepting the alternate hypothesis. But when we write our answer, we always focus on this null hypothesis. We say either we reject the null hypothesis or we fail to reject null hypothesis, like that. So this is the decision rule. Like if our z statistic is greater than our critical value or this p-value, then we will reject the null hypothesis. Otherwise, we will fail to reject the null hypothesis. Okay. So with that, we can interpret our results. That is, draw a conclusion in the context of the problem we are solving based on whether this null hypothesis is rejected or failed to reject. So now you might be thinking about the significance level. I said, right, we have to select a significance level. So what is the purpose of the significance level? The significance level or the alpha in a hypothesis testing is a critical threshold which determines the cutoff for deciding whether we have to reject or fail to reject our null hypothesis. So it is with the help of this significance level or with the help of this alpha, we assess whether the observed result is due to random chance or it actually represents a real effect. So in short, you can understand alpha or the significance level as the probability of making a error, like a type 1 error. Type 1 error is rejecting a null hypothesis when it is actually true. So when you say alpha is equal to 0.05, we are saying that there is a 5% risk of concluding that a difference might be existing when it actually is not existing, right? So that is why I said usually we give 5% leverage. See, alpha 0.01 means there is 1% risk only. That means it is very, very, very accurate. We don't generally use 0.01% and all unless it is say COVID-19 vaccination. We generally go with 5%. Okay. So this alpha is what helps us identify the critical value, which is the cutoff point for rejecting the null hypothesis in a z-test. So just like how we have now by hearted the value of pi as 3.14, the z critical values of this common alpha values will also be by heart for seasoned statisticians, right? So for our case, don't worry. Usually they'll be given along with our term and examination question. So we can use that and determine the critical value. So don't worry about it. So this was a step-by-step instruction on how you can conduct a z-test. I hope this process is clear for you. Now, if the process is clear, well and fine, we can go ahead and see a real term and examination question and look at how it has been implemented, the step-by-step, how we solve for this particular examination question. We will look at it. Okay. If you are not clear with these steps, I suggest you take some time and understand the steps properly before attempting to solve the question. Okay. So in hope that you understood, let us move ahead. So the first question is like this. We are given a sample of 100 students from a large population of students, and the mean height of these 100 students is told to be 64 inches. So take note here, we are given the sample mean. Sample mean is how much? 64 inches. This is the sample mean. The null hypothesis should be that there is no particular difference, like we are agreeing with the question asked, and alternate hypothesis is we are disagreeing. So that is why null hypothesis is yes, we are regarding the population mean as 66 inches. We are saying yes, the question asked is correct, and the alternate hypothesis is the opposite of it. Okay, so that was the first step. We wrote down our null hypothesis and our alternate hypothesis. Now to perform a z-test, we need to know the sample's mean. Is the sample mean given? Yes, it is 64 inches. We need to know the hypothesis population's mean. Do we know that? Yes, this is 66 inches. Now, what else we need? We need to have the sigma value, the standard deviation value of the population. What is that? 4 inches. Sample size, what is that? 100 students. So, we have all the values we need to calculate the z statistic. When I calculated the z statistic, in the interest of time, I applied all these values and I calculated it. It came to be around minus 5.0. Okay. Now, we are given in the question itself that for a significance level of 0.05, the z critical value is minus 1.96. The z critical value is already given. So what we got minus 0.5 and we have to compare it with minus 1.96. So on one hand we have minus 5.0 and on the other hand we have minus 1.96. This is our z statistic and this is our c critical, right? So what was the decision rule? If the z statistic is greater than z critical, we have to, so if the mode of, so we don't have to consider this negative sign and all, we can just consider it as 5 and 1.96. If the z statistic is greater than, the mode of the z statistic is greater than the z critical value, then we can reject the null hypothesis. Otherwise, we will fail to reject. That was the decision rule, correct? So, what can we see over here? Accordingly, we will definitely have to reject our null hypothesis because z statistic value is definitely very greater than the z critical value. So we are rejecting. So we cannot regard, that means we cannot regard that the population mean height is going to be 66 inches. Okay. So that much is clear. So we have no choice but to reject our null hypothesis as per the interpretation rule. Now if you look at this value, z statistic, okay, it is minus 5.0 and the critical value is minus 1.96. So when you look at this, minus 5.0 is far lower than the cutoff value of minus 1.96. This means that our population mean would be far lower than the sample's mean at 0.05 significance level. So once you do all your calculations and comparisons, you can conclude your answer by stating that it is not reasonable to regard that the population's mean height would be 66 inches at 0.05 significance level. But one thing that I want you guys to note over here, which I also want you guys to highlight when you conclude your answer, is that at significance level 0.05, we cannot accept the null hypothesis. Like we have to reject our null hypothesis. Say alpha was 0.01. Then maybe things would have been different. So only because we are assuming a critical level of 0.05, we are rejecting the null hypothesis. So that part you have to stress when you are concluding your answer. Okay. So that is how you can write solve for such questions, such hypothesis testing questions. I hope this question is clear to you, and if suppose a question like this comes in your term and examination, I hope that you will be able to solve for it very well. Now I had said that we will be also discussing about chi-square test, because using chi-square test also we had one term and examination question for testing the hypothesis. So chi-square test, as we spoke in the introduction, it is used to check if observed categorical data fits a theoretical or an expected distribution, or we have to compare values. All these cases we will be using chi-square test. Now even in chi-square test there are little variations, like if the requirement is to test if an observed frequency is consistent with a binomial distribution or Poisson distribution, like that we will use the chi-square goodness of fit test. Okay, so that the rule of whether we have to go with the goodness of fit test or anything else, you can also note it from the number of variables that are given to you. Like as I said, right, if you are given one variable, one set of data, and you are asked to test if that data fits a normal distribution or binomial distribution, something like that, that is if it fits something else. then we go for the goodness of fit test. But otherwise, say if we are given two variables and we are asked to find any relationship between the two variables, then we will go and test for its independence. Or if we have to compare those two distributions across the groups, then we will go for homogeneity test. So like that, there are a few variations of this chi-square test also. But the basic thing in this chi-square test problem solving is to use the chi-square test, we will be dealing with categorical data and frequencies. Okay, it will not involve any kind of mean or standard deviations directly. That is the key concept here. So the core calculation for whether it is goodness of fit test or test of independence, homogeneity test, whatever it is, the core of a chi-square test involves computing the chi-square statistics. Like in the last test, last example, we had to calculate the z statistic. Like that here, we will calculate the chi-square statistic or chi-square statistic. So to compute the chi-square statistic, we can use this particular formula, that is x square, which is nothing but the chi-square statistic, is equal to summation of OI. OI is the observed frequency minus EI, that is the expected frequency. So OI minus EI, the whole square, the whole thing divided by EI, the expected frequency. You calculate that and then sum everything up, you will get the chi-square test statistic. Okay, so the way we calculate, so this is the basic formula here, but the way we calculate this expected frequency, this EI, and the interpretation of the result, that is what differs between goodness of fit test or independence test or homogeneity test. Okay, now in the interest of time, we will be explaining only how to calculate the goodness of fit test in this video, because the term and examination question we will be solving today asks for this chi-square test, specifically this goodness of fit test. So in the interest of time, in this video we will be talking about the goodness of fit test. Okay, so how can we perform the chi-square goodness of fit test? Let us look at that. So like any hypothesis testing, the first step here also is to state the hypothesis, the null hypothesis and the alternate hypothesis. Then we will calculate the expected frequencies, which will help us to identify the theoretical distribution, like uniform distribution or binomial, whatever it is. So we have to use the distributions formula or the characteristic to calculate the expected frequency for each category. So the formula for calculating this expected frequency is EI is equal to N into PI, where EI is the expected frequency for the particular category I, N is the total number of observations, and Pi is the probability of category I under a particular theoretical distribution. So how to calculate this Pi? This Pi value is what will change, this Pi value is what will change depending upon your theoretical distribution. Like if it is a normal distribution, you have to use that formula. If it is a binomial distribution, to calculate Pi, you have to use that NCR, P raised to R, Q raised to N minus R, that formula. So like that. So this is why the expected frequency calculation will be different based on the theoretical distribution we are saying, because of this variation in calculating the Pi value. Once you have the Pi, then EI is the same only. N into Pi will give you EI. Okay, so that was the second step. The third step is, once we have EI, we can start the computation of our chi-squared statistic. So what was the formula? We just saw now it is OI minus EI whole square divided by EI sigma. So sum of that, then we'll get the chi-squared statistic value. Now once we have the chi-squared statistic value, it doesn't end here. We have to calculate one more thing, that is the degree of freedom. Okay, we have to calculate the degree of freedom. Now the degree of freedom for chi-squared test will be or is given as df is equal to k minus 1, and k over here is the number of categories. Okay, if additional parameters were also estimated from the data, like the mean for a Poisson distribution and all, then we'll have to subtract that number from the estimated parameters as well. So like that never comes in term and examination. So for us, we can say that the degree of freedom is df is equal to k minus 1, where k is the number of categories. That's it. Once we have the degree of freedom, we can next step is to find the critical value. So critical value For finding the critical value, we can use something called as the chi-square table at the desired significance level and the degree of freedom. So here also, don't worry, in term and examination we will be given the critical value. Like in Z test we were given the Z statistic, right? The Z critical value for the given alpha, that is significance level. Here also we will be given the critical value in the question, so don't worry. Okay, and now when we have the critical value and the the chi-square statistic, then we can compare these two and interpret the result. If your chi-square statistic is less than your critical value, then we will fail to reject, or if it is greater, we will reject. Same thing only, I just wrote it up and down. If your chi-square statistic is greater than critical value, reject it, else fail to reject it. That's all. The comparison is similar to the Z test itself. Okay, so that is how we can conduct this chi-squared goodness of fit test. Now let us take a numerical question and see how we can do this in practice. Okay. So this is the question which was asked. We are given the result of tossing 5 coins 3,200 times in a table like this. So 80 times no head came, 570 times only one head came. So 5 coins are tossed. Okay. So when 5 coins were tossed together, 80 times all the coins fell on tail. That is what is meant over here. 570 times only one of them showed a head, but 1100 times 2 heads came up, 900 times 3 heads came up, 500 times 4 heads came up, 50 times all 5 coins fell on head side. Now we are asked to make a conclusion whether the 5 coins are biased or not. So if and to help us with this decision making, some parameters like various critical values for various degrees of freedoms are also given. So which of these x square values, that is x critical values, we have to take depends on the number of categories. How many categories are there? From here we have 6 categories, right? 0 heads, 1 head, 2 head, 3 head, 4 head, 5 head, 6 categories. So what will be the x critical value? It is going to be this one. Okay, sorry, number of categories is k. We have to minus 1 from it. df is equal to k minus 1. So we have to calculate, we have to take this one. Okay, the 5. That is what we have to take. Okay, anyway, I'll again explain it once again when we come to that in the solution part. Okay, so now let us go step by step. So the first step is to formulate the null and alternate hypothesis. So what will be our null hypothesis here? That the coins are fair. And what happens if the coins are fair? The data will follow a binomial distribution with p is equal to 0.05. That means how to find our EI? EI is equal to expected frequency is equal to n times pi. Pi, how to get the value of pi? Pi, you have to use the binomial distribution formula to get the value of pi. And what will be the alternate hypothesis? That the coins are biased. Okay, so now we can calculate the frequency, expected frequency EI. We know EI is equal to n into pi. N is nothing but the number of times the coins were tossed. That means n is equal to 32,000. What about pi? So pi we have to calculate using binomial distribution. So we have to use NCR P raised to R Q raised to N minus R formula. So in the interest of time, I have calculated the value of Pi for each of these observations and given in this table. You have to calculate it yourself and make sure or confirm that whatever I have calculated is right or not. Now that we have the value of Pi and N, we can calculate EI for each of these observations. Again, that also I have calculated for you and I have given that in the screen here. Simple multiplication only. 32,000 into the value of, 3,200 into the value of Pi will give you the value of EI. So we have Pi, then we calculated EI. Now we have all the data that is required to find out the x square, that is the chi-squared statistic value. So for that, first what we have to do, we have to calculate OI minus EI the whole square divided by EI. That is the first step. Then second step, we have to sum all of those observations up. So first I will calculate this OI minus EI the whole square divided by EI. Okay. So again, so it comes to be like this for each of the observations. Once that is done, we can sum all of this up and we'll get x square is equal to 58.8. This is the chi-squared test statistic. Now, once we have the chi-squared test statistic, we have to get the value of what? We have to get the value of chi-squared critical value. Chi-squared critical value. X square critical we have to get. We have x square statistic. Now we need x square critical value. To find the x square critical value, we need to know the degree of freedom, because we are given a table like this with what would be the x square value at 5% level of significance for various degrees of freedom is given. Which of these values have to be taken is what matters. So what is DF? DF is k minus 1, where k is the number of categories. How many categories we have? We have 6. Why do we have 6? We have 0 heads, 1 head, 2 head, 3 head, 4 head, 5 head. So 1, 2, 3, 4, 5, 6. That is why k, that is the number of categories, is 6. So if k is 6, what will be our DF? DF is going to be 5. 6 minus 1, 5. So what is the x square value we have to take? We have to take the x square value corresponding to the degree of freedom, that is 5. So x square critical value is 11.070 according to the table. Now we have x square and x square critical. We can compare them, right? And when we compare them, what do you see? We are getting x square value as 58.8, whereas x square critical value is only 11.070. So x square value is much greater than x square critical. So what we have to do? We have to reject our null hypothesis. What was our null hypothesis? The null hypothesis was that the coins were fair. So if you reject the null hypothesis, what is our conclusion? That the coins are biased. The coins are not fair. So there you have it. So that was it for this video. We discussed on 2 questions from hypothesis testing concept which had come up in our term and examination as numericals. I hope that I can accept my hypothesis that your confidence in solving the numerical problems have now increased. Whether I can accept it or reject it, you will have to tell me in the comment section. Anyway, so we will meet again in the next video where we'll be looking at some other types of numerical questions which have also come up in the past, so that you are prepared to face them if they do show up in your term and examination. Until then, all the best for your upcoming examinations.